In this video, I'll be covering problem 3, solving all equations from A to K. So to get started on this quadratic equation, remember if it's quadratic, you should have two solutions. We do inverse operations to isolate our variable by undoing addition or subtraction first, then undoing multiplication and division. But then to solve for x when you take the square root of both sides, this breaks down to 25 and 2, then 5 and 5, where we've got a pair of 5s. So don't forget we have to have two solutions, so we'll have x equals plus or minus 5 square roots of 2. Remember, you can store your values as x also. If we were to store 5 square root of 2, store it as our x value, and then type in our equation, 2x squared minus 100. It should come out to equal 0. It does. Now if I do negative 5 square roots of 2, store that as x. Oops. Plug it back into this equation with our negative 5 square roots of 2. It also equals 0. So both solutions are correct. For part B, we have to isolate the radical first, so we subtract 5 first from both sides, remembering that just because we see a minus sign does not mean we add. The 5 that we're trying to get rid of is a positive 5, so we need to zero it out by subtracting 5. That leaves us with the opposite of the square root of 3g minus 9. But remember that that's really a negative 1 being multiplied. So if we divide both sides by a negative 1, we isolate the radical finally. At this point, we want to square both sides. So that gives us 3g minus 9 equals 9. Then we add 9 to both sides and divide by 3. So g equals 6. Let's go ahead and check our work. Let's store 6 as our x value. Then type in 5 minus the square root of 3x minus 9. And if our answer is correct, it will come out to equal 2. And it does. Next, for C, we have a cubic equation. We still have to get the x cubed by itself, so we undo addition or subtraction by first adding 35. Next, we divide by 2. Oops, I'm sorry. I didn't even add my value. Sorry. 397 plus 35 is 432. When I divide that by 2, I get 216. And then to undo cube root, or x cubed, we take the cube root. We get the cube root of 216. Now if we type in cube root of 216, math 4, 216, we actually find that it is a perfect cube, 6. So let's take our value of 6 and store it as x. Then type in our equation. And if our answer is correct, it will equal 397. And it does. So x equals 6. For D, to isolate, to get rid, the radical is already isolated. We just want to eliminate the radical. To undo the cube root, we cube both sides. That leaves us with 2c minus 1 is equal to 8. 2 cubed is 8. Add 1 to both sides. 2c equals 9. Divide both sides by 2, and c equals 9 halves. Please don't give me a decimal value. So if we type in 9 halves and store it as x, then type in our equation, the cube root, so math 4 of 2x minus 1. If we hit enter, we hope that it equals 2, and it does. So we know that this is correct. Next, for E, we have to get rid of a, which please remember we can also think of this equation as 6 times the square root of a. Please remember here that anything to the 1/2 power is the same as the square root, because your index is 2, and it's a to the first power. Okay? So the first thing we do is subtract 9 from both sides. But then we divide by 6, and we get the square root of a is negative 3 halves. Hopefully you get to this point and go, oh yeah, we can't get negative 3 halves because the square root of a number can never equal a negative. But however, if you were to continue and square both sides, you would have ended up with 9 over 4. Now, if we were to store this value, 9 over 4, store it as x, and then substitute it back in here, either in the first form or the second, either is fine. I'll type in 6x to the 1/2 power plus 9. If our answer of 9/4 is correct, it will come out to equal 0. But it doesn't. It comes out to equal 18. So I go back and check. Well, I'm going to make sure that I stored my value correctly and that I typed it in correctly. I did. If it doesn't come out to equal 18, then that's how you know that's not the solution. And in fact, you can know it's no solution as soon as you get the square root of a equaling a negative value. So for F, this is going to require a little bit more work. We always, if we're given two radicals in an equation, we need to isolate or make sure we have one radical on either side. Really the only thing we can do at this point is to square both sides. It drops the radical on the left. However, on the right, it doesn't. So this is the square root of t plus 2 minus 5 written twice.
Announcements this afternoon. There is Apex that it will be held in the Media Center today and on Thursday.
If we multiply radical times a radical, it drops the radical.
Today, and it will be held on Tuesdays and Thursdays.
If we multiply our outer terms here, we get negative 5 times the square root of t plus 2.
Students, please check this list to ensure that you are eligible to play in tomorrow's
Then our
game.
inner
And
minus
also,
5
ASAP
square root of
Project
t
Equals
plus
students,
2.
Make sure that you report to 1
Negative 5 times negative 5, positive 25. So all I did here was double distribute. Again, the square root of t plus 2 times the square root of t plus 2 is t plus 2. The square root of t plus 2 times negative 5 is negative 5 square roots of t plus 2. Same thing for our inner term here. And then negative 5 times negative 5 is 25. Simplify both sides. The most we can do here is combine these two and combine our 2 with our 25. Come down a line here. So I'm going to have t minus 10 square roots of t plus 2. And then 2 plus 25 is 27. So if you look at it now, we're down to one radical, which is our objective. Now we would solve this like we would any other equation by setting it equal, or excuse me, by isolating our radical. So if I subtract a t term from both sides, I get t minus 7 equals negative 10 square roots of t plus 2 plus 27. I can subtract 27 from this term, and that gives me t minus 34 equals negative 10 square roots of t plus 2. Next, I divide both sides by negative 10, and there's really not much else I can do. However, at this point, I can square both sides because my radical was isolated. So really what we're going to need to do is square this quantity and put it over 100. So if I square t minus 34, that means I write it twice. Over negative 10 squared is 100 equals. But remember, when I squared the right side, I dropped the radical. Now what I want you to do is not be intimidated by this and recognize that we can multiply both sides by 100. And this will cancel out on the left. So let's go ahead and multiply that out. That gives us t squared. Negative 34 and negative 34 for our outer and inner give us negative 68t. Negative 34 squared, or times itself, is positive 1156. And then on the right side, if I distribute, we have 100t plus 200. At this point, it's gotten down to a simple quadratic equation, and all we have to do is make sure we move our terms over to set this equal to 0. So I'm going to subtract 100t and subtract 200. Those cancel out, so now it'll be equal to 100. That's minus 168t, 1156, minus 200 is 956. And now as a quadratic equation, we can try to factor it, although it might not be very pretty, or we can go ahead and solve it in our calculator by graphing. And since that requires so much work, I'll let you all do that at that point. But of course, you could use quadratic formula for completing the square as well. So if I type in x squared minus 168x plus 956, I have to recognize that these are much larger values. So I need to, if I look at my graph, I'm not going to see them. Or definitely not both of them. I can see one of them. This does open up, so that tells us there's one here and then one probably over to the right, that it came down and then goes back up. So we can zoom out, zoom, 3, enter. We still don't see our other one unless it was right there. Let me see if I just zoom, go back to standard viewing window. And let's see if it's an integer. I know it's something between 5 and 6 because that's when it hits the x-axis and changes from a positive y to a negative y. And that might be really far out when it changes again. Let's see. Might be a really large value. So let's go ahead and find that one by putting in 0 in y2. Second trace 5. I'm going to move my x over. Like I said, we knew it was between 5 and 6. Enter, enter, enter. And we get 5.9 approximately. And let's see, that was the one that was really close when we zoom out. I'm going to go to window here and make my x max 100. We certainly, of course, could be using quadratic formula to solve this. And there it is, okay, just by zooming out. Or adjusting our window rather than zooming out. So all I did, guys, is I went to window and changed my x max to 200. Second trace 5. I know it's way over here at about 200. Maybe around there. And we get 162.1. So those are two values that we can find by approximating. Like I said, we could find the exact values by quadratic formula. So this one will be an extra credit problem on the test. I do hope that you all will attempt that and have time. But you are going to be expected when you go to pre-cal to be able to solve radical equations with radicals on both sides or with two radicals, and that's how it would work. So all we did was square both sides. You just have to be careful of your algebra. Then once we had one radical, we isolated it by solving again, getting it by itself. We squared both sides, multiplied here so we wouldn't have a fraction, and because it was quadratic, set it equal to 0 to solve. So from there, again, quadratic formula would be the best way probably to find those exact values. So it will be extra credit, but please take the time to think through that because it'll be worth a lot of points. But don't attempt it until after you've completed all the problems on your test. All right, next for G, we are solving a rational exponent problem. So the first thing, we want to do is divide both sides by -2. We get x to the 3/2 equals 54 divided by 2 is 27. Now I am going to expect that you can convert this to to a radical and then simplify it. So remember when you have x to the 3/2, to isolate x, you invert the exponent and raise both sides to that power. So this gives you 6 over 6, which is 1. And this, remember, is the cube root of 27 squared. Now, if you think about what you already know, hopefully you know the cube root of 27 already. The cube 27 squared means 27 times 27, but 27 is 3 times 3 times 3, and you've got another 27, which is 3 times 3 times 3. Because you're finding the cube root, both these 3's come out, and you get 9. All right, so if we store our value for x, 9 store as x, enter, and type in negative 2, x to the 3/2 power. We want it to equal negative 54, and it does, so our answer is right. All right, next, moving on to h, we have 81 equals the quantity 4x plus 17 to the 3/2 power. Similar to what we just did in the last problem, we want to raise both sides to the 2/3 power. By doing that, it isolates, or it eliminates this rational exponent altogether. Remember, this is the cube root of 81 squared. 81 can be written with the base of 3, or you can just realize that it's 81 times itself. 81 is 9 times 9. So if you break it down slowly like this, you can find it as well without having to rely on a calculator. All right, so let's make sure this makes sense. So 1, 2, 3, 4, 5, 6, 7, 8. So if I have 8 3's, so 3 to the 8th power, that should be the same thing as 81 squared. And it is. Okay, so all I did was break them down into 3's. So because it's the cube root, I can pull out a 3 and a 3, and I'm left with a 3 and a 3. So this is 9 cube roots of 9 equals 4x plus 17. I'll make sure the one on your test doesn't come out to have that in there. But to get x by itself, and I do want an exact answer, you would then subtract 17 and divide by 4. So that's the exact value. So it may look really ugly, but let's type it in, making sure that we use parentheses around our numerator. So if we have 9 cube roots of 9 minus 17 divided by 4, and we store that as x, then we want to go back here and plug it in here and see if it comes out to equal 81. So 4x plus 17 to the 3/2 power. Hopefully it comes out to equal 81. And it does. So while it looks ugly, these are all the correct steps. You'd want to simplify that radical, then subtract 17 and divide by 4. All right, for I, man, all these I put up here had 3/2 powers. All right, so to get this by itself, you want to move the 10 and then get rid of the negative, and then you'll be able to get rid of the exponent. So our first step would be to subtract 10 from both sides. Divide through by a negative 1. Raise both sides to the exponent inverted here, so 2/3. So this is the cube root of 64 squared. That's 64 times 64. 8 times 8 times 8 times 8. Two times 8, each 8 is 2 times 2 times 2. So you're going to have 4 groups of 2, so 2 to the 4th power on this side. And 2 to the 4th power is 16. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So remember, we have on this right side, raising both sides to the 2/3 power cancels it out, and we just end up with x minus 10 equals 16. Add 10 to both sides, so it's real simple, and we get x equals 26. So let's store 26 as our x value. Then type it in our original equation up here. We want to make sure that it equals negative 54. So 10 minus the quantity x minus 10 raised to the 3/2 power. Hopefully it equals negative 54, and it does. So that tells us that 26 is correct. So all these steps, guys, I want to see these steps. You'll lose a point if I don't see them, but if for some reason you're stuck, you can do 64 to the 2/3 power to check your work. So 64 to the 2/3 does come out to equal 16. I just expect to see this because students should be able to think through like that, okay? So you'll lose a point if you don't have that work, but you could still get the solution correct if you put it in the calculator. And last one, actually, I didn't have the right letter even. It was K. Remember when I taught you to do this? We said that if you have a negative exponent, you still just raise it to the negative 2/5 power. So this will cancel because it's negative 10, or excuse me, positive 10 over 10, which is 1. But then when you have a number raised to a negative exponent, it becomes positive when you flip it. So if we flip 1 over 64, we get 64, and that'll be to the 2/5 power. Now you could type that in your calculator, but again, I'm going to expect to see the work. So 64 to the 2/5. Actually, it means you're going to have a radical, so you won't be able to just put that in. But if you do the 5th root of 64 squared, we actually already did 64 over here, guys. We broke down 64, and it ended up being all these 2's. See all these 2's here? So I'll do it again, though. 64 squared means 64 times 64. That's going to be 8 times 8, which is 64, times another 8 times 8. And each 8 is 3 2's. Okay? But this time, it's 5th root. So 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. So you've got 2 groups. So a 2 comes out, another 2 comes out, and you're left with the 5th root of 2 times 2, which is 4. So that would be 2 times 2, which is 4, 5th root of 4. All right, so when we put this in our calculator, 4, math, we want 5th root, so this is how you have to do it. You have to type in 4 times 5 for the index, and then choose math 5. So 4 times the 5th root of 4, and we store it as x. Okay? Now, when we type it back in here, x to the negative 5/2, we want it to equal the same value as 1 over 64. And 1 over 64 does match up with a decimal, so that means our answer is correct. All right, and that concludes problem 3.